Hello friends, welcome to EPG Pathshala. I am Professor S.P. Singh from Faculty of Management Studies, Gurukul Kangri University, Haridwar. Today we are going to study Module 17 on factor analysis. After studying this module, you shall be able to understand the factor analysis, list the conditions for factor analysis, know the methods of factor analysis. Factor analysis is a method for determining the number and nature of underlying variables among larger number of measures. It is a method for determining k underlying variables from n sets of measures, k being less than n. A factor is a construct, a hypothetical entity that is assumed to underlie tests, scales, items, and indeed measures of almost any kind. For example, a number of factors may underlie intelligence, verbal ability, numerical ability, abstract reasoning, spatial reasoning, memory, and others. Factor analysis is generally an exploratory or descriptive method requiring many subjective judgments by the user. The method is similar to principal components, although factor analysis is more elaborate. In one sense, factor analysis is an inversion of principal components. In factor analysis, the observed variables as linear functions of the factors are modeled. In principal components, new variables that make linear combinations of the observed variables are created. However, in both dimensions of the data are lessened. It is to be noted that in PCA, interpretation of principal components is often not very clear. Sometimes a specific variable may contribute significantly to greater than one of the components. In an ideal situation, each variable to contribute significantly to only one component is preferred. For that purpose, the technique of factor rotation is applied. Physiology, health, intelligence, sociology, and sometimes ecology and others are the disciplines in which factor analysis is involved. Uses of factor analysis. The technique of factor analysis has various uses. Number one, scale construction. Factor analysis could be used to develop concise multiple items scales for measuring various constructs. Attitude measurement and scaling, the process of developing a multiple item scale that typically starts generating a large set of items relating to the attitude being measured. This is done as part of exploratory research. Factor analysis can reduce the set of statements to a concise instrument and at the same time ensure that the retained statements adequately represent the critical aspects of the constructs being measured. Suppose we want to prepare a multiple item scale for measuring the job satisfaction of skilled workers in an organization. As the first step, we would generate a large number of statements numbering say 100 or so as part of exploratory research. These statements could be subjected to factor analysis, and let us assume that we get 3 factors out of it. Now, if we want to construct a 15 item scale to measure job satisfaction, what could be done is to separate 5 items in each of the factors having the highest factor loading. Establish antecedents. This method reduces multiple input variables into grouped factors. Thus, the independent variables can be grouped into broad factors. For example, all the variables that measure the safety clauses in a mutual fund could be reduced to a factor called safety cause. Psychographic profiling. Different independent variables are grouped to measure independent factors. These are then used for identifying personality types. One of the most well-known inventories based on this technique is called the 16PF inventory. Segmentation analysis. Factor analysis could also be utilized for segmentation analysis. For example, there could be different set of two-wheelers customer owing two-wheelers because of different importance given to factors like prestige, economy consideration and functional features. Marketing studies. The technique is also extensively used in marketing and can be successfully applied for new product development, research for product acceptance, advertising, copy development, pricing and branding studies. For example, the factor analysis can be used to establish the attributes of brands that influence consumers' choice, get an insight into the media habits of various consumers, identify the characteristics of price-sensitive customers. Conditions for a factor analysis. Factor analysis requires some specific conditions that must be ensured before executing the technique. Metric data. Factor analysis exercise requires metric data. The data should be either interval or ratio scale in nature. The variables for factor analysis are identified through exploratory research which may be conducted by reviewing the literature on the subject. Researchers carried out already in the area by informal interviews of knowledgeable persons, qualitative analysis like focus group discussions held with a small sample of the respondent population, analysis of case studies and judgment of the researcher. Standardization. As the responses to different statements are got through different scales, all the responses are required to be standardized. The standardization assists in comparison of different responses from such scales. The standardization is carried out using the following formula. Size of the sample. The size of the sample respondents should be at least 4 to 5 times more than the number of variables. Correlation. The application of factor analysis assumes that the initial set of variables is highly correlated. The hypothesis to be tested may be written as null hypothesis, correlation matrix is insignificant. That is, the correlation matrix is an identify matrix where diagonal elements are 1 and off, diagonal elements are 0. Alternative hypothesis is correlation matrix is significant. Test of sphericity. The test is carried out by using a Bartlett test of sphericity which takes the determinant of the correlation matrix into consideration. The test converts it into a chi-square statistics with degrees of freedom equal to k multiplied k minus 1 by 2, where k is the number of variables on which factor analysis is applied. The significance of the correlation matrix ensures that a factor analysis exercise could be carried out. Kaiser-Meyer-Hawkins statistics. The KMO statistics takes a value between 0 and 1. For the application of factor analysis, the value of KMO statistics should be greater than 0.5. The KMO statistics compares the magnitude of observed correlation coefficients with the magnitudes of partial correlation coefficients. A small value of KMO shows that the correlation between variables cannot be explained by other variables. Factor analysis. There are basically two steps involved in a factor analysis. Extraction of factors. The first step in factor analysis is to decide about the factors to be extracted from the given set of data. The centroid method, the principal component method, and the maximum likelihood method could accomplish this. Factor loadings. If a test measures one factor only, it is said to be factorially pure. To the extent that a test measures a factor, it is stated to be loaded on the factor. If a test contains more than one factor, it is said to be factorially complex. It is important to determine the number of factors, the tests loaded on the various factor, and magnitude of the loading. Communality. The entries in the H square are communalities. It exhibits the amount of each variable accounted for by the underlying factors taken together. It is a measure of the percentage of variables variation that is explained by the factors. Comparatively, high communality indicates that not much of the variable remains after whatever the factors represent are taken into consideration. They are sums of squares of the factor loadings of a test or variable. For example, the communality of test S is 0.48. The communality of a test or variable is its common factor variance. For example, the communality for variable V can be computed as 0.81 square plus 0.01 square is equal to 0.66. Independence of extracted factors. The two factors should be statistically independent. This means the correlation coefficient between the two factor scores should be 0. Rotation of factors. In order to interpret the factor loading matrix called the component matrix and to be able to interpret the results in a better way, a factor rotation is desired. Many of the software have a provision for varimax rotation which results in independent factor. The purpose of rotation is to have the factor loading in such a way that they are either close to 0 or to -1 or to +1. This means that the factor loadings are high on some variable and low on some other variables. The results are obtained after varimax rotations. In order to interpret the result, a cutoff point is decided. There is no hard and fast rule to decide the cutoff point, but generally it is taken above 0.5. Now, using 0.7 as the cutoff point, the variables corresponding to factor 1 having a factor loading above 0.7 are considered. Naming the factors. Naming of factors is more of an art, as there are no rules for this purpose except giving names best representing the variables within the factors. Friends, in this module you have studied the factor analysis, the conditions for factor analysis and the methods of factor analysis. Thanks for visiting EPG Pathshala.